Good morning, class. We are looking at chapter 6, Trig or trigonometric functions, section 6.2, graphs of other trigonometric functions. So we looked at graphs of the sine and cosine functions, and now we're going to look at graphs of other trigonometric functions, tangent, cotangent, cosecant, and secant functions. The objectives are graphing functions of the form y equals a tan omega x plus b, y equals a cotangent omega x plus b, a y equals a cosecant omega x plus b, and y equals a secant omega x plus b. For sine and cosine, we know the period is 2 pi, and a complete cycle is drawn from 0 to 2 pi. We can cut this 2 pi into 4 equal sub-intervals. When we divide 2 pi by 4, becomes pi over 2. So 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. That gives rise to 5 key points: 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. So 3 x-intercepts, 1 max, 1 mean. So 1, here's 1, here's 2, here's 3, and here's 4 arcs. We do the same thing for cosine. And it looks like that. 1, 2, 3, 4. We also noticed that sine and cosine are ultimately the same. If you move the graph of cosine by pi over 2 to the right, you obtain sine x. Now y equals a sine omega x, where a is positive, omega is positive, period is 2 pi over omega. So in short, for sinusoidal functions, whether y sine x or cosine x, the period t is equal to 2 pi, amplitude is 1. For y equals a sine omega x or y equals a cosine omega x, where omega is positive, the period is t, 2 pi over omega, amplitude is the absolute value of a. In these two cases, the coefficient of sine or the coefficient of cosine is 1. That's the amplitude. Now, graphs of tangent, cotangent, cosecant, and secant functions. So we are going to look at tangent, and just what we did with sine, we are going to graph using points. We get familiar with the shape, and then we use that as an essential elementary function. So y equals tan x. If we want to go just, for example, from minus pi over 3 to pi over 3, we can pick up a few numbers. Now, let's go with easy numbers. Common arcs. There, if you pick anything else, you have to use a calculator. Okay. Starting with 0, you know tangent is 0. Pi over 6, is square root of 3 over 3. So minus power 6 is the same thing but negative. Negative square root of 3 over 3. Power 4 is 1. Negative power 4 is negative 1. Power 3 is square root of 3. Minus power 3 is negative square root of 3. And these numbers, the approximations in using decimals is for the sake of graphing. So we have the following pairs. So carefully plot the pairs. So along the x-axis, here 0, 0, this is power 6, power 3, power 2, and we are stopping at power 2, just for the sake of argument. Just to give you an idea. The shape appears to be looking like the graph of y equals x cubed. Remember that for graphing tan x, it's helpful. Now, what about y equals tan x? Let's look at the same points and add more. So the same points and add more. When we add more, we know at pi over 2, it's undefined, and so is as minus pi over 2, because tangent is sine x over cosine x, and cosine is 0. At pi over 2 and at negative pi over 2. So what does that mean? That gives rise to a vertical asymptote, x equals minus pi over 2 here, and x equals pi over 2 here. That's the meaning. The pairs are the same as here. We are added pi over 2 and negative pi over 2, and again, the reason they are undefined, remember tan x is sine over cosine. So if you think of this as a rational function, it's a fractional function. Even a fractional function can have vertical asymptotes wherever the denominator is 0. So if you graph it carefully, it looks like that with those two dashed lines, x equals minus pi over 2 and x equals pi over 2 as vertical asymptotes. We continue indefinitely on both sides because tangent, just like the rest of trigonometric functions, are periodic functions. So if you look at one cycle, a complete cycle, and you continue indefinitely, x equals minus pi over 2, x equals pi over 2 represent vertical asymptotes for the first piece, and then 3 pi over 2, 5 pi over 2, and so forth. 0, 0 happens at this point, therefore n pi 0. So let's look at information about tan x. Because y equals tan x equals sine over cosine, okay, domain is all real numbers except what makes the denominator 0. So x can be any number except what makes the denominator 0. What makes cosine 0? Odd multiples of pi over 2. Remember, pi over 2, 3 pi over 2, 5 pi over 2, or on the negative side, negative pi over 2, and so on. The range, no restrictions, all real numbers. And you know that tangent is an odd function. You also know the period is pi. That's why when you graph a complete cycle, we go from negative to positive pi over 2. And the reason you go from negative to positive to cover everything as far as the range is concerned. Vertical asymptote is where cosine is 0. So this one that can't be becomes the equation of VA, vertical asymptotes. And the x-intercept, going back to this format, y is 0 when the numerator is 0. That means sine is 0. That means x equals n pi. So x-intercepts occur at n pi, comma 0. So that gives you a lot of information, and the fact that the tangent is sine over cosine is truly helpful. And if you want to find anything here, just remember t is pi. So this one, if the t changes, you can put it here, even here. All right, let's graph y equals 2 tan x minus 1. We're going to do the transformation, and I want to remind you of what happened in the previous page. In the case of y equals tan x, the period is pi. VA x equals 2n plus 1 times pi over 2. X-intercept at n pi is 0. And t is pi over omega in general, by the way. So when you look at this one, in front of x, there is no number. There is no coefficient. Period is pi. If there is any number, you divide by that. Take a look at this one. If it's omega, this is not w, this is omega. And so if t is pi, the vertical asymptotes happen at the same point, 2n plus 1 times pi over 2. X-intercepts the same thing in pi 0. So let's start with the basic tangent y equals tan x. Let's multiply it by 2. When you multiply it by 2, there's a vertical stretch of 2. That means 0, 0 doesn't change, but pi over 4 comma 1. This one becomes pi over 4 comma 2. Negative pi over 4 comma negative 1 becomes negative pi over 4 comma negative 2. Nothing else changes, the same vertical asymptotes. Let's use a different color actually for the other. Let's apply the negative one. That means subtract 1. That means bring it down by 1 unit. So what happens? This one, pi over 4, comma, you're going to bring this down so it becomes 1. And this one, negative pi over 4, negative 2, bring it down, becomes negative 3. 0, 0, you bring it down, becomes 0, negative 1. So that one, let me also use a different color on that. So this point moves to this point. So this is the final graph, y equals 2 tan x minus 1. Now, it has no bearing on the domain and range. It does have an effect on location of the intercepts, and that actually you have to set equal, this one, set it equal to 0 and solve, and we can figure it out when we do equations, just for the sake of argument. Example 2, we want to graph y equals 3 tan 2x. First and foremost, when you look at this, you notice this true, and by the way, except sine and cosine, the rest of them, they don't have an amplitude, okay? Because it has got to do with the max and mean. So this one, omega is 2, so the period is pi over omega. That means pi over 2. So this is omega. So a complete cycle, we go from minus pi over 2 to pi over 2. But now we go from minus pi over 4 to pi over 4. Basically, you cut this in half. So one complete cycle. You cut this in half, goes from minus pi over 4 to pi over 4. This is just one complete cycle. And in essence, vertical asymptote that was x equals pi over 2 and x equals minus pi over 2 is changing. So first, again, let's look at the vertical asymptotes here. Instead of pi, replace the pi here, everybody, with pi over 2. Replace this pi with pi over 2. So it becomes 2n plus 1 times pi over 2 over 2 or pi over 4. So that's why I put them in different colors to make a point. So pi over 2 instead of pi. That's how you get that. So take a look. This is the original basic tan function looking like y equals x cubed. One complete cycle goes from minus pi over 2 to pi over 2. In other words, in this case, t is pi. You cut this in half, you get pi over 2. So you go from negative pi over 2 to pi over 2. Okay. So and I don't use brackets because the endpoints are not included. That's one complete cycle, everybody. Okay. In this case, it goes from negative pi over 4 to pi over 4. That's the first thing we should notice. Let's multiply it by 3, so we are not changing anything yet as far as the asymptotes are concerned. When you multiply this by 3, that means you stretch this vertically by a factor of 3, and therefore this one goes to pi over 4, 3. This one too goes to negative pi over 4, negative 3. Nothing else changes. Everything else stays the same. Now, if we replace the x with 2x, there is a horizontal compression by a factor of 2. In other words, you push these two vertical asymptotes closer. That's the essence. So instead of from minus pi over 2 to pi over 2, we're going to go from minus pi over 4 to pi over 4. That would be the new asymptotes. Okay, that 0, 0 doesn't change. But this one, pi over 4, half of it becomes pi over 8, 3. Minus pi over 4, half of it, that means minus pi over 8, negative 3. So take a look. This is what we get. This is what? Pi over 4 divided by 2. And this one is what? Minus pi over 4 divided by 2. and the rest of them. Again, you pay attention to a complete cycle. And so y equals 3 tan 2x. That's what you have here. If we want to find the x-intercepts n pi 0, you replace the pi with pi over 2, n pi over 2 0. Okay, so replace the pi with pi over 2. Again, so let me just write that. So we have vertical asymptotes, and we have the x-intercepts in times pi over 2 0. So you choose n being 1 is pi over 2, being 2 is pi, and so on and so forth. So it's similar to the previous question. I just want to make sure we understand what happens here. The effect of this, okay, is to have the period, which is normally pi, divided by omega. Please understand x over 2 means 1/2 x. Divide by 1/2 and you get 2 pi, which means normally we go from minus pi over 2 to pi over 2. So take a look. Then first of all, over here, change the pi to 2 pi. If you change it to 2 pi, then with the 2 cancel each other. Let me just actually write this. So this one becomes 2n plus 1 divided by 2 times 2 pi These two cancel each other, and we get VA is 2n plus 1 pi. Change this pi to 2 pi also. So 2n pi 0 would be the x-intercepts. Okay, so first, the basic tangent function. And it goes from negative pi over 2 to pi over 2 because t is pi. In this case, ultimately, it's going to go from negative pi to pi, okay? Negative pi to pi because you are stretching along the x-axis. So first, let's multiply by 3, which is, I believe, what we did in the previous page, right? So we changed the 1 to 3, negative 1 to negative 3. So far it looks like the previous page. And then we're going to replace the x by x over 2. There is a horizontal stretch by a factor of 2. So what happens is this. So again, I want to pay attention to a complete cycle. X equals minus pi over 2 becomes x equals minus pi, and this becomes x equals pi. 0 doesn't change. This one you multiply by 2, becomes minus pi over 2 negative 3. This one you multiply by 2 becomes pi over 2 3. So take a look at this one. Okay, take a look at this one. X equals pi over 2 becomes x equals pi. This point, get the effect. Okay, and look at the intercepts. 0 doesn't change, but this one is 2 pi 0, as I mentioned. This changes too. So the x-intercepts take place at 2n pi 0. So 0, 0, 2 pi 0, 4 pi 0, and so forth. And the vertical asymptote at odd multiples of pi, minus pi, pi, 3 pi, 5 pi, 7 pi, and so forth. So that's various transformation of tangent. So graph of y equals 3 times tan of x over 2 looks like what you see. What about cotangent? Reminding everyone, cotangent means cosine over sine. Reminding everyone, if you think of it as a rational function where sine is 0, you get vertical asymptotes. Sine is 0 when x is n pi, okay? And at the same time for the domain, x can't be n pi. So if you pick up a few points, and now remember for cotangent, even for the inverse, we went from 0 to pi. The reason a complete cycle goes from 0 to pi because it's a continuous function, there is no break. Otherwise, there will be a break. Pi over 6, cotangent is square root of 3. Pi over 4 is 1. Pi over 3 is square root of 3 over 3. Pi over 2 is 0. 2 pi over 3 is minus square root of 3 over 3. 3 pi over 4 is the same as pi over 4, but negative, because in the second quadrant is negative. So negative 1. 5 pi over 6, the same as pi over 6, square root of 3, but negative in the second quadrant. We can add 0 is undefined. If you put 0 here, you get undefined. And if you put pi, the same thing. So 0, undefined, pi, undefined. That means those are the vertical asymptotes. So if you plot the pairs, looks like almost y equals minus x cubed. Remember that in your mind, but of course goes from 0 to pi. And so here's the information. Again, of course, you continue indefinitely on both sides. So let's go back. This is one complete cycle. And you continue indefinitely on both sides. Y equals cotangent x or cosine over sine. Domain, denominator can't be 0. Sine x can't be 0. X can't be n pi. Range from negative to positive infinity. There is no restriction. It's an odd function, as you know, and the period is pi. So where sine is 0 would be VAs. Sine x is 0. That means VA happens at x equals n pi. X-intercept where the y is 0 when the numerator is 0. Cosine is 0 at 2n plus 1 times pi over 2. And of course, if it's cotangent omega x, pi over omega. So what I want you to notice, the period is pi. So in all of these cases, when the period changes to anything else, change this one. So pay attention, this is that one, and so forth. Okay, so you really want to pay attention to that. And that way, you know how to find the answer if the question is asked. So one more time, this is extremely important. The period is pi. So in all of these cases, when the period changes, change this or this to t. That's all. We can figure it out that fast. Okay, replace the t as the t changes. Okay, that's exactly the same thing you do for tangent. So very straightforward. For tangent and cotangent, that's the change you make. Let's go with y equals cosecant x. We know it's 1 over sine x. So we are going to graph y equals sine x. That's all. And we know how it looks like. So that's the graph of y equals sine x. Then flip it over, meaning this becomes that, just for the sake of arguments, and I'm going to erase it. So if you look at this part, just this part, flip this over, and it becomes this. Okay. But remember, at 0, because you flip it over, it creates vertical asymptotes, because VA sine x equal to 0, x equals n pi. Remember, when x is n pi, sine is 0. So wherever the 0, the intercept happens for sine, those lines are VA's, vertical asymptotes. So let me erase mine. So you graph the sine, and then you flip it over. That's all. It's that simple. So what would be the information when y equals cosecant x? We know it's 1 over sine x. X can't be n pi. Why? Because sine x equal to 0. Sine x equal to 0, x equals n pi. That's one. So x can't be n pi, which means VA has the equation x equals n pi. Range. What was the range for sine? For sine, the range was from -1 to +1. So when you flip it over, all numbers are included except what's in between. -1 itself is there, +1, -1 is there, but in between those two numbers, it doesn't belong to the graph of the blue function, the y equals cosecant x. And as you know, cosecant, just like sine, is an odd function. The period, just like sine, is 2 pi. And so VA becomes n pi, and we don't have any x-intercepts. Now, if the period changes, so all you have to do, if you happen to come with a new t, so replace this pi with a new, if you come up with a different t here. So if you are looking to find vertical asymptote, replace this pi with whatever the new period is. And the domain You want to exclude that, again, replace that. It's very straightforward, everybody. So I should say actually half of t, so it's t equals 2 pi, t over 2, t over 2. Okay, t is 2 pi. And t is 2 pi, this is half of that. So half of that, pay attention to that. Let's look at y equals secant x. That's 1 over cosine. That means we're going to graph y equals cosine x first. Looking like that. And so wherever you have zeros of cosine, you have vertical asymptotes, just for the sake of argument. VA cosine x equal to 0. I'm talking about VA for secant, which means 2n plus 1 odd multiples of pi over 2. And then so flip over the graph. So flip it over. When you flip it over, since this is 0 and this is 0, this becomes, the two become vertical asymptotes. That's a complete cycle. And here's the graph. Let me erase mine. And now y equals secant x over 1 over cosine x domain. You set the denominator equal to 0 and you exclude it. X can't be 2n plus 1 times pi over 2. Therefore, the vertical asymptotes are that. Range, just like cosecant, all real numbers, except the numbers between -1 and 1. And you say minus infinity to minus 1, union 1 to infinity. That's how you write it. It's an even function because cosine is even, so is secant, and t equals 2 pi, just like cosine. And so what happens if you want the VA or the domain when the period changes? So t over 2, actually, you replace the pi with t over 2, the same thing here. Okay, if things change. Let's look at y equals 2 cosecant x minus 1. And then again, I'm reminding you y equals cosecant x is 1 over sine. Domain x can't be in pi. Range is all real numbers except between -1 and 1. We say minus infinity to -1, union 1 to infinity. The endpoints 1 and -1 are included. Odd, it's an odd function. T is 2 pi, v is x equals n pi. There is no x-intercept. So actually, secant and cosecant, none of them have x-intercept. So t equals 2 pi. Domain x can't be in pi, and VA is x equals n pi, just like the basic one. So you graph y equals sine x, and then cosecant x. So I'm assuming everybody is following that. So here's the sine x1. Complete cycle. Just look at this part. And corresponding to this part, we have this, and the rest of it, because it continues indefinitely on both sides. And so this has coordinates power to 1, 3 power to -1. So let's multiply this by 2. That means you stretch it vertically by a factor of 2. So what happens is this point, power to 1 becomes power to 2. This point becomes 3 power to -2. Okay. Nothing else changes. By that, I mean, look at the asymptotes, they remain unchanged. Or graph 2 sine x. I hope you see that if I wanted to graph 2 sine x, would that be like this? And then flip it over. Okay, that's a second method. Now -1, bring it down by 1 unit. Subtract 1 vertical shift, bring it down by 1 unit. Which means now this point, which has coordinates power to 2, comes down to power to 1. This one comes down to negative power to -3. This comes down to 3 power to -3. That's the meaning of it. Which is the graph of y equals to cosecant x minus 1. So look at those points. Maybe now I erase this and I go with, let's see, this color. So look at these 2 points. Everything else stays the same. The domain vertical asymptotes remains the same for what we have. Of course, it does have an effect on the range. So all real numbers except between -3 and 1, just for the sake of argument. So the range is changing. Minus infinity to -3. This becomes -3, and this remains as +1. Okay. Two hallways of 3 feet and 4 feet. Hallway of 3 feet, hallway of 4 feet. Wide meet at a right angle. That's what it means. Show that the length of a ladder L is 3 secant theta plus 4 cosecant theta. This angle is theta. So is this one, so is this one. And so again, this angle is the same as this angle, is the same as this angle. And now we are going to say this distance is x, and this distance is y. So we want this distance plus this distance. So L, so this is 3 feet, this is 3 feet. This is 4 feet, this is 4 feet. We want L, which is the sum of x and y. So we are going to draw this. This is x, this is 3, this is theta. We want to be clear as to what's going on. So cosine theta is the adjacent 3 over x. So x is 3 over cosine theta. This one has the sides 4 and y and this angle theta. And sine theta is the opposite 4 over y, which results in y being 4 sine theta. So L is 3 over cosine theta plus 4 over sine theta. And this means 3 secant theta. This means 4 cosecant theta. That's the proof. So it's pretty straightforward. Graphing y equals negative 3 secant of pi over 2 times x. Let's graph this. Again, reminding everyone that y equals secant x means 1 over cosine x. And from here, we want to go to this graph, y equals minus 3 cosine of power 2x. Now, from cosine, we go to secant. That's the idea, since secant is 1 over cosine. We know how the cosine looks like. A complete cycle looks like that, with the t being 2 pi. So in this case, t equals 2 pi divided by pi over 2, resulting in 4. So just for the sake of argument, the graph which looks like that, and this is 0 to 2 pi, now it's looking the same from 0 to 4. This is 2 pi, believe it or not. Okay, so that's the idea. And therefore, this point is 2. -1, that's the idea. Okay. 1, 0, 3, 0. Again, normally this would be 0, 1. This would be what? Pi over 2, 0. Okay. 3 pi over 2, 0. 2 pi 1. Okay. Pi minus 1. Let's actually write all of those in red. So this should be pi over 2, 3 pi over 2. This should be pi. 4. Let me just write it in red again. 4 y equals cosine x. Or y equals cosine of pi over 2x. We change those numbers accordingly because the period of 2 pi has changed to the period of 4. So the graph looks like this. Again, take a look at what I have here for you. Let me use a red color here. I used red there. Let me use a green one. So this is 0, 1. This is 1, 0. This is what? 2, -1. 3, 0. 4, 1. Okay, just the way I have it. You don't need the numbers. It's clear. So let me clean up everything and just do those points. Okay. All right. So that's cosine of pi over 2x. And the 2 pi has changed to 4. Just very straightforward. All right. Let's multiply it by 3. That means vertical stretch by 3. So this becomes -3, the y coordinate, and this become +3. Okay. So this one is class 2 comma -1 4 comma positive. So this becomes 4 comma 3. This becomes 2 comma -3, and this is 0 comma 1 becomes 0 comma 3. So take a look at those pairs. Right? Again, just as an example, this one has coordinates 4 and 3. We want minus. That means the same thing, flip it over. The same thing, flip it over. Now, when you do that, the effect is, let's look at this one, for example, the blue one. At the coordinates 2, -3 goes to 2, +3, and 4, 3 goes to 4, -3, 0, 3 goes to 0, -3. And so the last step is this one. So we got cosine of power 2x, 3 times that. We flipped it over. And now we want the secant. So all you have to do over here, that's the graph of secant. Okay, and wherever you see 0. So understand, let's see what color I want to use. Wherever it's 0, this creates vertical asymptotes, and then flip this over and the rest of it. So it becomes the red one in essence, this 2 pieces and so forth. Those are the graphs that we are looking for, everybody. And so the period is 4. The period is 4, t equals 4. And let's change the pi here to half of that, everybody. Bring half of that here, 2. 2 and 2 cancel each other. T is 4. 2 and plus 1. Again, how did we get this? Notice what I did. I changed the pi to 2. I think it is fine. Let's quickly look at another method, second method. One, graph cosine x and then secant x. So this is the cosine x, and I want to show you this point, and 3. This is a complete cycle, and we extended on both sides indefinitely. This is a cosine, and the blue one is the secant. Let's graph y equals 3 cosine x, and therefore 3 sine x. So that means we are going to stretch. Again, look at the cosine. you're going to stretch it by a factor of 3 along the vertical axis, meaning, for example, here, which is 2 pi 1, becomes 2 pi 3, okay? And here's a pi, and this is also 0, 1, becomes 0, 3. This one is pi negative 1 becomes pi negative 3. So take a look at those. Look at those 3 points. This one, 0, 1 goes to 0, 3. This one, pi, as by the way, pi is about 3.14, so I hope you see that. So it goes to pi negative 3, and look at this one. This, you see, this is number 6. Remember, 2 pi is like almost 6.2. It's a little bit to the right of it. So now 2 pi 3. That's what we have here. We are going to flip this over. Negative 3 cosine x. So if you look at cosine x, this will flip over. Look at just this one. And then they will flip over. Take a look at what happens. The red one flips over, so does the blue one. And just look at those 3 points again. This point, which had coordinates 0, 3 goes to 0, negative 3. This one, which had coordinates pi, goes to pi positive 3. And this one that had coordinates 2 pi 3 now has coordinates 2 pi negative 3. It flipped over. And it's important to understand so far, case 1, case 2, case 3, t is 2 pi in all of those cases. So what happens now, for number 4, we want to graph this one, negative 3 cosine of power 2x, and then we flip it over. To get that, we need to remember that the t is 2 power 2 equals 4. So this period of 0 to 2 pi changes from 0 to 4. And that's the key, everybody. So what happens? 0, negative 3 doesn't change. But pi, 2 pi becomes 4. Pi becomes half of that, 2. So this now has coordinates 2, 3. And this one has coordinates 4, negative 3. So take a look at this one. 0, negative 3 doesn't change. This one, pi 3, 2, 3. Okay, so pi 3. and 2 pi negative 3 4 negative 3. So I hope it's clear to everybody.